projection on a line in 3D space. Okay, let's say I have a point P and a point Q. Let's say this is x1, y1, z1, and this is x2, y2, and z2. What we want to do is we want to project this. Now, what's a projection? So you have movies are projected on the screen, right? Similarly, a shadow is projected by the rays of the sun, right? So the shadow is the projection of our image. The only difference is here it is we are three-dimensional and the shadow is two-dimensional. So we say that is a 2D projection of a 3D object. Here we are not going into that kind of fancy thing. What we are looking at is projection of a line on another line. What is that another line? Let the direction cosines of the other line be L, M, N. So what we want to do is we want to project this line onto the other line. Just to give you a small example, let's say this is our x-axis, right? And this is our, here we want to project it onto the x-axis. Let's say this is x-axis. Now we just take a perpendicular drop, right? And this becomes the projection of this line onto x-axis. Similarly, we can take a projection onto the y-axis, right? Now here the cases are simple because we have x-axis and y-axis. So we know we can drop perpendicularly. But here we are talking of a random line on which we want to put project the PQ. Now let A and B vectors be the position vectors of P and Q. So which means what? P, Q. Let's say this is the origin. So position vector of P would be this and Q would be this. This is origin. So the moment, and this is A, this is, so which means PQ would be what? B minus A, right? So PQ, vector PQ would be equal to OQ minus O, which is nothing but B minus A, which means using IJK, we can write it as x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. This is PQ. Now the unit vector along the line whose direction cosines are L, M and L. Remember, we have another line whose direction cosines are L, M and N. Now its unit vector would be equal to L I plus M J plus N K. So projection of PQ along E would be equal to PQ times, which is B minus A times E. Now in Cartesian form, it would be x2 minus x1 L plus y2 minus y1 M plus z2 minus z1. In vector form, the projection of PQ along the line with L, M and N direction cosines would be this, and in terms of Cartesian coordinates it will be this. Now for projection along axis, right, x, y and z would be x2 minus x1, y2 minus y1, and z2 minus z1. If the projection of PQ along the given line is 0, that means the line PQ is perpendicular to the given line, right? It's in very simple terms, when the sun is exactly over it, right? What happens to the projection? Basically, the shadow disappears. Strictly speaking, it doesn't disappear. You know, yeah, in a way it disappears. A little bit of it will be there exactly below us, but that we can treat it as a point, and point is dimensionless. So there, if you notice, the sun is directly above us, so it is perpendicularly above us, perpendicular to the surface on which we are standing. Okay, now magnitude of the projection of PQ along the line E equal to the magnitude of PQ times E hat. So, you should be able to close your eyes and visualize this, that you have a line, and you have a line which may be parallel, or it might be pointing in some other directions, right? We want to project this line PQ onto that line. So how do we do it analytically? That is what this covers. Okay, so that is it as far as projection on a line is concerned. Bye for now.